All right, we're here with Eric and Tara, and we're going to be talking about how to connect the ESP32 and the ESP8266 to Azure IoT and how we've improved the experience. So we're excited to have you join. Hi everyone, welcome to the IoT Show. My name is Pamela Cortez. I'm from the Azure IoT team, and I'm here with Eric and Tara. So today we're going to be talking about the ESP32 and the ESP8266 and how to connect that to Azure IoT easily. So Eric, I would love if you give a little bit background of what you're doing on the team and what you've done in the past.
Okay. In the past I did a lot of things for Microsoft these last 20 years. But now I'm PM on the Azure IoT in the SDK team, precisely. And I work with Tara, one of our engineers, to build, of course, the SDK, but also have some good developer experience about this board. And when you try, the first time we tried to use this board with Azure IoT, it was a total failure. So we decided together, okay, we need to do something for our customers. We need to do something for the developer so they can use that and use that like a breeze.
Like a breeze, exactly. Okay, well, as he noted, I'm Tara Walker. I am an engineer on the team. I've done a lot of things, but most times I've been an engineer. I've even done some evangelism. I'm looking at him because he's a fan of that. But at my core, I'm an engineer, I'm a coder. And so I have had the lucky experience of working with the Azure IoT team to make sure boards like this work really seamlessly with Azure.
Yes, these are both my favorite people, so I just wanted to do that call out because they come from my background, which is devices and creating a better experience. When talking about the ESP32, which is a microcontroller by Expressive, it's a really popular Wi-Fi and Bluetooth microcontroller. We're also going to be talking about the ESP8266, which is just Wi-Fi, but it's just as popular. So I'm very interested, how are you making the experience better? Because I know myself designing with this ESP32, the experience always hasn't been amazing, so I'm super excited to hear what you've done. Yeah.
Okay. So everything starts with a code. So we try the code together and say, yes, it's working. So now we have to publish this code and help people to set up the machine because, you know, it's all about the tool chain and all the variable, environment variable, all this kind of stuff. And we really want to simplify this approach. So we created a Github repo. It's public since a couple of days. If I may, I'm going to present this repo to you.
Absolutely.
So, of course, it's on GitHub because everything is about open source, and we really think about open source, both of us. And of course, you will find at the root of the repo a big README with what is in the repo, the sample, but more than the sample, you can find here how to install the toolchain, or you set up your environment to be able to build, or to set up the sample. So, back at the beginning, on the repo, you will find two things. Samples to start with, and reuse a lot. But also, you see in this folder components, we have ported the Azure C SDK for this board. That means we change the thread model, all this kind of stuff.
Oh, perfect, yeah.
And we do that for the PNP, the plug and play preview, it's right now
brand
preview,
new,
and the non-PNP issue here.
Okay, perfect.
It's important to note that with the Tara works, it's just a copy paste. So you copy this folder, you pass it in your component folder in your actual solution.
Yes.
And just work.
Like a breeze.
Wonderful.
Like a breeze.
Yes. And I noticed with this, it's on Azure samples as ESP samples. For those who are just typing in ESP32 Azure IoT, there might be a lot of different repos that pop up. Did you want to describe like the type of repos that they might see?
Yeah, it's what's interesting about that is most of the repos they see are Arduino.
Exactly.
And we I think we have a pretty good experience there. But when you start talking about working with the RTOS and the IDF, we didn't have a good footprint there about how people would get started. Would you agree?
Totally. What was on the main thing. So in terms of samples, we have 3 samples in this repo. We have the first one you created without the plug and play. We have the one Deepti and another colleague of us created with the plug and play. And by the summer, we had an intern, Sarah Rashid, and she played with that with another board. It's 8266, and she made an amazing demo. And we asked her, "Do you want to publish with us?" Of course, she said. So we have these 3 samples. And they are really, really ready to start. So you clone the repo, you follow the instruction to install the toolchain, and that's it.
I love it, because before it was a lot of setting things up and trying to find which code samples to work with. And I think it's...
that is why we created a folder here with the install script.
Perfect.
So you have the install script if you run in WSL or in Linux, if you need to refresh your WSL, if you want to switch to the latest or the current build and this kind of thing, everything is on the script now.
What is really cool also about the script is we set up for you both stable, to Eric's point, and latest. And we've given you, with the script, it's a convenient script. So the setup one, you run, everything's good, you have both. But then the convenient script, let's say you want to switch between the 8266, the stable latest for ESP32, or just, 4133, whatever you want to do. You just pass that in, and we reset up all of the environment variables, point to the right tool chain, and you're off to the races.
Great. Great. So that's what I want to hear.
Like a breeze.
Exactly.
We spent a lot of time doing that.
We did, and testing. So that environment should be really, hopefully, seamless for people to get started with Azure IT, because that was the biggest hurdle most people who had not experienced ESP devices we faced in the team. And even I will tell you, as a person who was experienced with it, getting it onto Azure, I was a little surprised at the difficulty for somebody who was very familiar with getting ESP with in a cloud environment.
Exactly. And then for those who are interested in using Azure IoT Central, will this repo be easy for them to pick up and use with Central as well, just because you have plug and play support? And
Exactly. We did test this, even though it's not in there. So some of the samples, if you do find them, we have one out there for Central, and I think this one is maybe in the port repo, the expressive port repo. You could take that sample, copy it out of that repo, which is something you couldn't do before, and paste either one of the components in and run it, and you're off to the races.
Great.
That is also for your new projects as well.
Yeah, because I was always trying to find a nice firmware or a nice easy way to get connected to IoT Central with the ESP32. So this is great. I'm excited to test that part.
Let us know.
You can
share feedback. It is on GitHub, so we can do pull requests and then issues.
Exactly. Just open an issue if you find something weird or you don't understand. We are going to help you. Definitely.
Yes.
That's the plan.
Well, let's get into what it looks like.
Yes. The exciting part.
Let's get into what it looks like. And we're really going to get into the code, because that's the part I like the most, honestly. So we're in the sample that you will see in the repo. This is the starter sample, one of the samples that you'll see in the repo. And what's good about this, what we really tried to do, is you can not only run this sample and look at the experience and things of that nature, but what's really cool about it is you could take any piece of this and copy and paste it into your own application.
Love it.
Into your own. So that was kind of how we tried to format it. And let me explain that a little bit. So you'll see that I'm in ESP Sensor C. This has pretty much a bunch of sensors. So you could take this header file, the ESP Sensors H, and this header file, drop it into your machine, and you will have things like the OLED is there, the code for it. You will have the temperature sensor that's there. You see the OLED SSD 1306, a common one. You'll see the HTS 221, 2221, which is another common. So the common sensors that you would see are there. And this code here is actually something that you can completely reuse. You see I have it for this particular device, has an additional button on it.
Okay.
And you can have that button be user defined. So this code is in there for you to do whatever. Right now, it just says user defined button is pushed because I don't know what you want to do with it. So right now, that's what I have.
Keep it simple.
Yeah. Right. Hey, I like to keep it simple. I initialize the I2C bus. Obviously, that's already done for you. No need to do that. You have, the luminous sensor, but everything is really clear if you could see, about what is there and what you have to use. A good thing also about this, and we talked about it because we wanted it to really be something that people could not only consume, but could really use in the real world, is that because I have initialized the I2C bus in here, anything that is used on that bus with the sensors, you literally could just drop that code in here.
Yep.
And as you know, the ESP repo has a bunch of different other sensors that you can use that you can possibly add in there. So we tried to formulate it that way.
That's nice because there's such a huge community that's already providing example code and libraries for different sensors. So it's great that you make it really easy to just take certain code, and especially working with ES.
Yeah, it is a really rich environment. I really love, if you go to the forums, you're going to get an answer.
Oh, yeah.
The one thing that probably you wouldn't get there is the Azure stuff, right? Mm-hmm. So you'll see here, there is an Azure Hub client header file here, and then the subsequent Hub C file. Mm-hmm. And if you look at this, I'm just going to scroll up. So there you go. Hope you didn't get dizzy. That was fast. Where you put in after you configure your connection string, there. Anything that's happening with your Azure IoT is tagged as such. So when you look at your monitor, you can see, okay, my issue is happening here or there, and it actually, we tried to really document. And of course, you can take this out when you're ready for production. But from a development perspective, you really understand, hey, I just entered into processing and initializing the hub. Oh, hey, I just entered into, I've gotten connected. I just sent this message. We really tried to make sure when you're developing with this, you can of course take it out after you finish, but when you're monitoring, you really know what's going on when you connect to Azure at each point.
Yeah.
Exactly, exactly.
Important to precise that the IDF environment, it's a bit particular when you want to build.
Yes, let's talk about that. That's a great point to make. So as we all probably know, and people that are really familiar with Expressive knows their brand, their IDF is very particular about their build system.
Yes.
They want third-party tools or components to be in your component directory. Mm-hmm. And they come with a whole slew of components for you already. But for instance, for Azure IoT, that's why we made this, you drop the component in a component folder. And then they really kind of expect for you, then with that components folder, you have drop the folder in, it has the component make it the root of each of the folder, those kind of things. We definitely followed along with that. Your sources in main, I mean, this is not like a big rocket science. Your sources in main, you have your kconfig, and so we tried to make sure that we adhere to their build system. So when you run like a make list components, you will see if you just drop that in there immediately, ESP Azure is there for something that gets built into your component and working with that build system. Exactly. What you found before, which wasn't like a breeze.
I was going to say, that was not the process before.
we kind of missed a little bit on that before, where if you would take your sampling and try to drop our SDK in, it did not quite recognize it without a little tweaking, and we heard those issues, so we wanted to make sure we resolved that as well. So that's a good thing there. But as you see, this is pretty much ready for you to cut and paste anything you need. The last thing you'll just see here is there is obviously an example of a kconfig where we have the IoT connection string information about that. So you can use this as is or add to it. That's the whole point. And we want people to test this out, give us feedback, right?
Exactly. May I suggest we build something?
Yes.
We can,
because
of course, engineers and PMs don't believe you until it builds and they see it.
Exactly.
You said it before me, and I was like waiting for it.
She's like, build it. Okay, got it. So let's go. I'm in a WSL Windows subsystem for Linux. I have the Ubuntu distro of this.
Okay, perfect.
So I'm in, as you see, the folder. I have already built this because you don't want me to build on camera, right? Now, here's something I did mention. We did mention on here for people that are also familiar with embedded development as well as expressive. They see me typing make here. This is also supported with CMake. We made sure that you had both. Because Stable 3.3 for expressive is on make and CMake is in preview, we wanted to make sure for both experiences you had the ability to build on
There's
this.
going to be preferences,
And we don't want to denote your preferences, have at it. You can both build this with Make Monitor. You can use the IDF Pi, which is their new build for CMake, and run IDF Pi Monitor, and it works the same. So I just happen to be, since this is the stable version that I'm in, I'm just going to do Make Monitor. But no fear, CMake lovers.
That's why I said preference.
Right. We cover both of these. So if you're really familiar with expressive, you will note that there's a couple, I will mention while this is going into Monitor, there are a couple things you can do here. And I don't know, what I found is even people that are really familiar with expressive don't use these, but these have come so in handy for us to show. That went by really super fast. You can do a make list components or IDF Pi list components. That way you can verify that actually your components are actually in there. Obviously there's make flash, make monitor. I just did make monitor, so because I had this running already. So before we go to the device, let's just talk about what I was noting about. We really tried to make sure you have probably more information than you ever really want.
Hey, that's good.
So you'll notice anything that has to do with Azure has literally that tag I said, Azure IoT. Azure Info is starting to process the messages from the sensors, and you see it says that. And then you'll see things that are when it's actually talking to the sensor to get data, it actually tells you that. Hey, I'm doing the sensors, I'm getting humidity, I'm getting luminance, whatever. Okay, so he will appreciate this being from Europe. So if you look at this, it is in Fahrenheit. The function I built.
You had a pretty.
I had to because trust me.
He would have gone on you because of that.
They already have. So the function I wrote to grab the temperature sensor already does the math for you. Great. So you don't have to do the math. If you look at some of the sensor samples, it does that. But not only do you not have to do the math, I actually have a flag where you can see true or false if you want it in Fahrenheit or Celsius. Of course, of course, Fahrenheit being the right thing, true is that. Okay.
Actually, I don't feel very strongly either or. So.
I really just have to clown my European friends. So this is the device running it. Actually, physically is sending to Azure. And if you look at the board, I'm writing this information out to the OLED. So the temperature, the humidity, and light. What's funny is I think I saw one of the samples that said Lumi, and for the longest I was like, what are they talking about? But it's luminous is what they were talking about. But I was like, okay, light makes a lot of sense to me. That's what we're going to put. So if you look here, in addition to what you seeing processing and actually sending to Azure, and again, this information is telling you when accepted, if you look at the board, you will see these things being written and changed in real time. So if we could cover the light, it would change the light and things of that nature. So we tried to really make sure for all the samples that you had the information that was needed and you could really use this in real life.
Exactly, and this is the board that you just showed. It looks like the Azure IoT ESP32 dev kit.
Yes. So but this is a really powerful board in this dev kit. So it comes as is, obviously with the OLED, which is, if you think about some of even my favorite dev kits usually don't have OLED. It has a humidity sensor, accelerometer, humidity, luminous, pressure. It has a bunch of sensors on board, which is super odd for a board, especially of this size, to have so many. And like I said, also the user-defined button. One is obviously for reset, but then you have a user-defined button that you can also use, and it's on the board for something still this small, very powerful.
Exactly, and then you have access to your other pins with the connector, which I love too.
That was
that's what I found.
But you know what was cool? What was
Yep.
cool about this? Because usually you're trying to pull up pins and solder, right? And this plug right in and you're good. I thought that was really good too, because that means you also could use your Grove devices with this.
Yeah, the sensors,
Right, usually you can't. So that was really nice if you just want to test something really quickly and you don't want to be like me, like, oh, I think I have a little bit too much on there when I'm trying to burn something on. You have that option. This, like I said, I was really pleased to get my hands on this board when it was released. So that was very nice to play with.
Yeah. Exactly, cool. And those who are familiar with the MX chip dev kit that we have, you'll see that it's very similar where it has the OLED and all of the sensors. So it's just a great way to just get started quickly.
Yes.
With an ASP.
Yeah, exactly.
Yeah.
What I'll notice, what you note here too, if you're working with IDF, we talked about expressive, and people are probably really familiar that, yes, you can work with Arduino. MicroPython, which is really popular. Actually, I'll do a shout out to Dave Glover, who did a couple of samples with FreeRTOS and MicroPython. So this is running FreeRTOS, but just using the ESP build system. So actually, I think also what's good about it, even though this is for expressive, looking at some of the code will be good.
Yeah, and understanding the elements that you need and the C SDK when deploying to any constrained devices and getting it connected to Azure IoT.
Well, finally, I know that Eric, being PMN, wants to close out of things with a nice bow. I'm sure he wants to tell people what to do.
Exactly. What are some of the...
I think we have one slide for today.
Where do they go next to learn more?
Exactly. So the call to action here is really simple. Have a look at the blog post. Sorry about that. Slow on your machine because
I got too much running.
Okay, so have a look at the blog post because all the explanation Tara gave you is write it down. PR on the actual sample because you want to add something or you want to submit your crazy idea on the ESP board. Please PR. We're really delighted to have another sample on the
we want to see the feedback.
An open issue to ask any question. Of course, you can tag us, Eric, me, Tara, and also Pamela.
Yes, if you have any ideas for future IoT shows, definitely tag us. And if you have any questions, feel free, as Eric said, submit issues, follow up with pull requests. So I'm excited. I'm excited to get my hands on playing with this
You'll
dev
have
kit.
To tell us how we did.
Exactly.
For sure.
I'll share.
Shoot all complaints to Eric, though.
That's how it will work. You'll actually get Eric in the background submitting, pulling into your pull request. Well, perfect. Well, thank you so much for coming and talking about how the experience is so much better with this microcontroller, and I'm really excited for folks to go ahead and get started with it. So thank you for tuning in, and we'll see you next time.
Bye.